And I made you now the host. Ayan. So on my end, it's recording now.
Opo, recording din.
Okay, good, good, good. So ayun. Ayun po. Ano po, ano na rin ako ng option na ano nga ito? To have a rest week for Josh last week so that you can focus po sa recovering. So
Opo.
ayun pala, at least nauna po palang nag-recover si Josh.
Oh, siya, eh. Ako kasi
Mm.
tulong. Ah,
O yun
ah,
sir, isa pa yan. Kapag kulang po kayo sa tulog, definitely ay malaking factor yan for yung
siguro
progression ng disease or
kasi
ng disorder.
mas
Mm-mm.
mahaba yung tulog sa'min siguro rin, puwede rin na factor tsaka siguro
Yeah.
dahil bata
Tsaka
yun.
feeling ko kasi sir, mas complete ang tulog ni Josh. Eh, hindi ko alam, di ba sir, mas mahaba siya matulog
Yes sir,
talaga?
siya yung pinakamahaba sa amin tulog, ako yung pinaka-least tapos
Mm-mm.
yung edad din siguro dahil bata, mas malakas yung immune system and everything.
Mm-mm. Ayun, sige po sir.
Okay sir.
Mag-share lang po ako ng screen and then, ay, naka ano ako, disabled Josh. Can you make me a co-host? Gawin mo akong co-host. Sorry. Ayan, there you go. So that I can share screen.
Bawal po
I'll share screen. This one.
commoners, yung mga commoners bawal po sir.
Can you now see my presentation?
Indirect titration po.
Yes. Okay. And then I'll be putting it on a slideshow. Ayan. There. Anong nakikita mo? Full?
Wait lang po.
White. Okay. So, ibig sabihin, pero full ano naman siya. Not in
Full
the presenter's view.
full screen po.
Okay. Hindi siya presenter's view. Okay, we're good.
Posible kaya po pala na ano, kung let's say kung may
Hmm.
certain na indicator po kayo, tapos
Hmm.
may computer program po kayo, di-detect na yung kulay, tapos check na yung pH directly using
Ay,
yung data.
sorry. Again. You have an indicator.
Tapos yung given po na molarity or something, whatever, basta ano, meron po kayong
Mhm.
yung ano ng indicator. Tapos may camera, i-check na using yung parang photo kung ano yung pH.
Yung intensity ng color ng indicator.
Tsaka ano pong hue para malaman yung pH.
So that you can, parang you can detect nga, no?
Opo.
Pwede naman yun, kaso lang, yung hue kasi at saka changing ng color ng indicator, gagawa mo yun ng program, Josh. Pag ganun.
Opo. So, posible
Kunwari,
kaya
let's say yung ano, impossible yung sa ano, yung sa Pinopta kasi may colorless ka dun eh. Zero ang madedetect mo nun kapag less than pag acidic region, right? Kasi
opo.
colorless yun eh. 'Di ba? Tama ba ako? Hindi na detect let's say gawan mo ng detector or sa camera kapag colorless kasi walang absorbance yun.
Madedetect actually po, 0. Transparency.
Yeah. Zero ang value niya. So it means if you have a zero value for the detector, you'll also have zero for the concentration, right? And it's wrong for the
Baka
H plus.
kung ano po, let's say po program na po, let's say for
Yeah.
parang
So ibig sabihin, ang limitation nga ng detector mo should have your indicator should have two colors for the acidic or basic region or any transition
or pwede kaya pong
color mo.
dataset. Pwede kaya po parang dataset.
Yeah, pwede rin naman yun, blue or yellow. Usually naman meron yung mga yan. Ang worry ko naman dito, totoo naman yun, nagbabago yung color niya. So, yeah, pwede yan. Actually, theoretically pwede yan, Josh. You can actually calculate the hydronium ion of your
Yung ano po,
solution
yung
using
program
the indicator's intensity. Tama yun. Kunwari, blue and yellow, Josh, BCG, hindi bromothymol blue yata yun. Meron tayo niyan dito eh. Wait lang ha. Hanapin ko very fast. Ayan. Wala pa kasi tayo dito. Pero nasa handouts mo na to. Ayan, may nakikita ka?
yun, may
Ano?
sampling.
Yeah, indicators?
Opo.
Okay, good. So let's say metal violet. So at pH 1, metal violet is colorless. Pero if you will see, no, or if you will notice, at different pH from 2 down to 12, different intensities of violets ano, or different hues ng violet. With that, you can actually approximate the concentration of hydronium ion. Pwede yan. Pwede rin 'to, Josh. Ito ngang metal violet mas ano siya, eh, 'no, I don't know if this one is challenging kasi one color lang siya kung by
Hindi nga
indication
po
'no,
yan,
kasi
kasi kung pareho
blue
po
to violet lang siya.
opo,
Mm.
kung pareho
Pero
yung hue,
tignan mo 'to.
saturation na lang po yung hahanapin.
Ayan, tignan mo 'tong bromo ito lang yung sabi ko, ito yung limitation nung magagawa mo kasi kapag may colorless, let's say phenolphthalein, orthochrysophthalane, and thymophthalane, you cannot use this for approximation ng H+ 'no, kasi may colorless, transition range ka, eh, right? So,
Opo,
however, for others, you can use them. Let's say, we'll have ito yung sinasabi ko, bromophenol blue, BPB. Yellow and blue yan eh. Okay? So, at acidic region, you'll have the yellow
po, kung ano,
color.
kung colorless po yung sa phenolphthalein, is it even
Mm.
viable to use phenolphthalein? Is it even a question? Kasi puwede naman po another
Yes! I mean, this is, uh, for this one tingnan mo ang intention dito nung gumawa is just to check the color of phenolphthalein from 1 to 12. And if we will notice, yung 1 to 8 mo, colorless talaga siya. So, ibig sabihin, kasi we have prepared solutions there with pH 1, 2, 3, 4. But if you will notice, we cannot distinguish. Kunwari, paghaluin mo 'tong 2, 3, 4, iba-blind mo siya. Hiwa-hiwalay siya, pagsama-samahin mo siya, hiwa-hiwalay na test tube, then 2, 3, 4. Can you indicate which one is 2, pH 3, pH 4 using your, let's say, detector?
libo?
Hindi na, 'di ba? Yun yung sinasabi kong limitation nung
Hmm,
maki-create mong detector. Kasi nga dapat requirement mo may color talaga dapat so that absorbance can happen. Okay? So,
opo.
yeah, puwede yan yung iniisip mo. Eh, let's say ito, bromophenol blue. All throughout naman may color siya, eh. Ang challenging naman dito, I don't know kung hindi kasi ako magaling talaga sa mga programming and all. So, ipo-program mo naman 'to na kapag, ang yellow ay I don't know kung paano 'to yellow dapat sa mga acidic. Tapos kunwari kapag basic, mababa na yung yellow mo or at no no absorbance at all 'no, for the yellow one. Then, dapat nasa blue region naman. Kasi alam ko RGB ang minimix, right, for the programming?
Puwede rin po inisip ko rin po HSL na ano, for
Ang
yung
HSL is more ano,
yung saturation,
comprehensive,
so yung sa
saturation siya ng colors.
lightness po and its hue.
Okay. I see, I see.
It will work po for phenolphthalein kasi
Yeah,
sa lightness tsaka transparency na yun.
lightness and transparency. Ang iniisip ko by ano by lab, transparent talaga yan, yang mga yan. Ito,
Opo,
transparent yan. So I don't know if transparency will change, let's say, from pH 1 to 7. Kunwari lang 'to Kasi sa Baybay Eyes, as in talagang transparent sila. And they will almost have the same transparency. I don't know kung computer or ang magde-detect. For sure, baka makakita siya ng minor differences and we can actually correlate that to, let's say, pH 1, pH 2, pH 3, etc.
opo.
Okay?
Yung
You
sa
might
ano
try. You might
opo,
try.
yung sa
Mura
computer
lang yung mga itong metal violet, ano 'to Josh, ano ngang tawag diyan? Colorant, dye 'to. Majority naman dito ay dyes. Actually mga dyes 'tong mga 'to, ginagamit pa nga yan sa mga pants, sa shirts. So mabibili 'tong mga yan. Metal violet, bromophenol blue. You try to choose your indicator and then try to, create a program wherein you want to have a, comparison 'no, for the standards. Gawa ka ng standards mo like pH 1 hanggang 12 and then gagawan mo siya dun sa program mo na kapag pH 1, yellow na ganito ang value. I don't know, kunwari let's say
opo.
1.72. pH 2, yellow pa rin siya, but the value, let's say, is 1.38. Ganun na lang, no? Pababa siya. Let's say,
Iniisip ko nga
pH
po
5
kasi
mo pinakamababa.
opo,
Yeah.
yung sa computer ko po kasi kailangan ng final
Hmm.
project, so inisip ko baka ito or kaya isa pa. So, ito nga po ito yung gawin ko nga po, pH detector.
Mhm, puwede rin 'yan, puwede 'yan. Pero meron pa nga akong mai-introduce sa'yo, paano kapag double indicator?
Double? Ano po yan?
Yes, we can do that sa chem, double indicator. You mix 2, hindi naman siya
Para
mix
para
talaga.
dalawa pong range, kung let's say dalawa pong
Yeah, stepwise siya. Let's say, puwedeng mag-a-add ako parang ganito, Josh, puwedeng mag-a-add ako ng bromocresol green sa unang portion ng titration ko, and then I'll add phenolphthalein sa second part ng titration ko. How can your program, adjust for the changes, 'no?
yun po yung ano, good
See?
question.
Maano 'yan, maganda 'yan, pero maganda yung programming mo kung ganyan kasi madali yung ano, yung sa, ano nga ito, computation nung mga mixtures. Sa mixtures kasi yan, nagagamit. Meron ba dito? Ayan, matuturo ko 'to sa'yo, 'wag kang mag-alala.
Wow, dalawa pong
Anyway,
equivalence point, dalawang equivalence.
oo, ang dami, madami na 'yan. Actually, fina-finalize ko naman na yung ano natin, file, pero kasi feeling ko aabot ng 200 slides ito. So,
Tsaka ano po pala, nakita ko na-notice ko sa mga ano, yun nga po yun sa kanina po, yung kaninang slide.
yeah,
Na-notice ko po yung mga indicator gano'n sila lahat. Yung mostly, yung nakita kong mga diagrams, nawawalan
hmm.
ng feedstock sa nagiging double band O.
Later you'll see that, Kasi mga ano lang naman 'to, changes lang sa, um, ah multiple bonds, pati yung sa aromaticity, puwede ring
Opo.
changes dun sa ano mo, sa electrons mo. For the non-bonding electrons of your, electronegative atoms like nitrogen, oxygen, nasa organic kasi yung dahilan. So,
Ayun,
ang nangyari dito, Josh, yung magbibigay sa'yo ng explanation, si organic chemistry, but the application will be anachem. So
opo.
parang yun dahil nagbabago siya ng kulay, okay, we can use this as indicator, Anakim will benefit. But if you want to know the explanation, why do you have changing colors for the different indicators? Si organic ang magbibigay ng explanation diyan. And in fact, we can actually approximate yung mismong values nung kung saan siya magbabago, let's say wavelength, kung saan siya pinaka nag-a-absorb, na-approximate yun, Josh. No, may ano yan, may tally yan. I'll teach you that one in organic chemistry. Yan, ayan medyo gamay-gamay ko yan yung mga kasi related yan sa instruments, eh. 'Pag heavy organic na talaga, ayan medyo hindi ko na yan kaya kasi ang dami, dami, dami talagang nangyayari sa organic chemistry. So, yep. Anyway, ay by the way baka mag-organic chemistry tayo within the week or next week. So, kasi mahaba naman 'tong, ah, titration. Okay. So, I think, we can now proceed. Review lang muna tayo, Josh, 'no, for the indirect titration. If you will recall, indirect titration, I'll go back lang dito. 'Pag hindi ako nakatingin sa'yo, nakatingin talaga ako sa inyo na kasi naka-ano lang ako, second screen.
Opo,
Ayan. So, this one, again when you say indirect titration, it's quite similar with the back titration. However, back titration kasi it's a technique. Though, however, this one is also a titration technique. Ang ginagawa natin dito sa indirect titration, we are not titrating directly the analyte. Instead, the analyte will be reacting with a species or a chemical reagent for a preliminary reaction. So that's the reason why for indirect titration, it's very important that we'll have a preliminary reaction. So ngayon, anong condition for the preliminary reaction? Your added reagent that will react to your analyte must be in large excess and need not be accurately measured. So ang condition lang natin dito, Josh, is ma-make sure mo na yung reagent na magre-react kay analyte ay in excess. Why?
para sigurado po lahat mag-react.
Very good. Yun yung gusto natin. All of your analyte must react to that reagent. Ngayon, ang mangyayari dito, di ba, reaction nito. You will form a product. So, one of the products can be titrated. Ayun, no? So, one of the products of this preliminary reaction is the one that reacts with your titrant. So, ngayon, yung titrant pala natin, nagre-react siya sa mismong product nung analyte and nung unang reagent na dinagdag mo. So let's say we'll have this, no? An analyte and then reagent to form a product here. Your product will now be titrated against a titrant to form the product, no? Titration products. The titration products here are not important unless magkakaroon siya ng rules sa calculation. Another thing, yung concentration no added reagent, it's not also important here unless magkakaroon ulit siya ng part siya ng calculation, no? So, most of the time, we make sure naman yung reagent pang dito will be enough for the analyte's concentration. So, we make sure that all analyte will react with your reagent so that you'll form the products, no? Okay. So, I think na-discuss ko na ito last time and sinolve pa natin ito, no? So, ngayon, ayan. Ang isang classical example, no, ng indirect titration will be Kjeldahl method. So, ito ay na-discuss ko na sa'yo last time. Can you explain, Josh, kung ano nangyayari sa Kjeldahl? Yan. Very, very specific kasi ako dito. Lahat ng estudyante ko dapat alam nila kung paano nangyayari ang Kjeldahl.
Yung alam ko yung parang flowchart nangyari.
Yep, andito na siya. Yung setup mo for the distillation of ammonia. Sa Kjeldahl method, you are trying to determine the percent nitrogen in your sample. Question, Josh, what are your possible samples? You want to determine the nitrogen of what?
Amines, mga ganun.
Amines? Anong amines? Sample, I mean sample substances.
Mga ano mo, mga organic compounds na
Okay,
nitrogen.
good. Organic compounds. So if we have organic compounds, we can determine the nitrogen, percent nitrogen using Kjeldahl. And what are the usual organic substances that you can use Kjeldahl
Mga
for
urea.
nitrogen determination?
Urea.
Hmm?
Urea.
Pwedeng urea. Ang urea ay present sa anong substance? Or material?
Mga ano mo,
Mga kinakain natin, ginagamit, ganyan.
ammonia, mga ano po na, mga ammonium compounds.
Yeah, ammonium compounds kasi ang madedetect dito sa Kjeldahl method. Pero ano yung samples mo, possible samples mo? Correct, organic substances yan. And usually they are, pag narinig mo kasi yung Kjeldahl, automatic, yan yung mga may isip mong sample eh. Number one, food. So, yung food kasi di ba may nitrogen yun? Kasi let's say, meat, carbohydrates, wheat, ano pa ba? Cereals, milk, pwede rin yan, no? So those are usual samples for Kjeldahl. Pwede rin ba yung fertilizer sa Kjeldahl?
Siguro po, mga ammonium sulfate, yun.
Correct. Kasi ang fertilizer ay technically may nitrogen. So we can still determine nitrogen from your fertilizers. O explain mo, anong nangyayari sa Kjeldahl method? So anong unang process? You have your
Dadigest,
sample.
tapos i-digest na po with something.
Very good. Ida-digest mo siya. Ano yung pinang-digest mo? Dito
I
yan,
don't know,
ilalagay mo yung sample mo dyan.
mga base.
O hindi base. Hindi base. Hindi base ang ida-digest mo dyan. Anong pang-digest mo? What's your pang-digest mo for your Kjeldahl? Anong pang-digest, Josh?
NaOH, KOH, mga ganun po.
Hindi. Hindi nga base eh. Hindi siya base digestion.
Pwedeng acid mo.
Hindi pwede. Acid talaga. Yan. Kasi Joshua, when you say a method, it means it's very specific. Kaya nga sabi ko sa'yo, pwede kang gumawa ng pangalan mo eh. Let's say, Joshua method. Pwede yun. As long as specific yan, magiging specific siya ngayon, 'no? So, ang Geldan method, ang una mo ay yung substance mo or yung sample mo must be acid digested. Usually, what acid is being employed? Anong acid ang ginagamit dito sa Keldal? Very particular ako dito, Joshua Keldal, kasi usual 'tong mga tanong, si Keldal. Kapag nag-ano ka, ano nga tawag dito, kapag titration ka, it's impossible that you will not pass through Keldal. Kasi si Keldal ay laging nadi-discuss. Napakadami kasi niyang application, let's say sa agriculture, sa food industry, nutrition, etc. So, magagamit mo siya, organic chemistry. Ano yun? Ano mangyayari? Ano palang ginagamit na acid usually for Keldal? Acid digestion mo. Yes,
Hmm,
what's your acid?
mga H2SO4 mga gano'n.
Yon, H2SO4, sulfuric acid talaga, no? So we have acid digestion using sulfuric acid. So acid digestion, okay? Using sulfuric acid. And then after ng acid digestion, several hours yan, 2 to 3 hours depending on your sample, no? So after ng acid digestion, Josh, ano na mangyayari? Ano nang next step mo for your Keldal?
Ah, Yun nga po.
Para saan pala yung ano, para saan yung acid digestion? Why do you need to digest your sample?
Hmm, para maano po siya, tawag dun, para
Anong
ma
dine-determine mo?
para maano po yung N, yung ammonium or ano.
Okay, good. Yung nitrogen mo, gusto mo siyang i-release from the
Opo.
organic compounds. Kasi 'di ba naka-bind yung mga ano or bound yung nitrogen mo in your organic compound. So, using acid digestion, your nitrogen will be free from your organic compounds, no? So ngayon, may nitrogen ka ng palutang-lutang. So, but we cannot detect nitrogen alone. Ayaw mo maging nitrogen gas yan, mahirap yung maging analyte, no? So, anong gagawin mo after acid digestion? So that's correct, no? That's the first one. The organic sample will be digested using sulfuric acid and a catalyst is added there and added to convert any organic nitrogen or bound nitrogen to ammonium ion. So naging ammonium ion na ngayon siya. Kasi nga acidic NH4+. So ano nang susunod yan, Josh? Ang ammonium mo ay acidic and it's in the solution. So anong kasunod dito, Josh? Tingnan mo sa distilling class mo. Look for the setup. Anong kasunod ng distilling class? Tingnan mo, ano mangyayari dito?
Maano na po siya, tawag dun, i-he-heat na po siya.
Ano naka-digest ka na. Kunwari, tapos na yung acid digestion mo. What will
Di
happen next?
Di-distill na lang po siya.
Paano mo siya madi-distill? Kasi ammonium pa siya eh. Right? Ayun, no? Ammonium ion siya.
Lalagyan na po somewhere sa NaOH bar something para ano.
Okay, good. Dito yan. Usually, bubuksan mo to, Josh. Tapos, tsaka ka maglalagay ng OH to neutralize the solution. So, anong OH yung pwede mong gamitin dito? Ito yung either sodium hydroxide, potassium hydroxide. Usually, strong bases will be enough to make the digested solution basic. So, ngayon, ano mangyari sa ammonium ion mo, Josh? Your ammonium ion will be converted into what? From acidic na ammonium, ginawa mo, kasi ang ammonium is NH4+. Ano mangyayari kay NH4+, Josh? Pag naglagay ka ng base, strong base, let's say NaOH. Yes, ano mangyayari kay ammonium?
Maano po siya, tawag dun, magiging NH3 tapos it will
Okay,
be
good. Magiging NH3 siya. Ngayon si NH3 mo, dadaan yan sa fractionating column mo dito. Yan, papupunta yan. Then condenser.
ba't kailangan po
Then
pala ng
babagsak siya
fractionating
dito.
column?
Yes, go ahead.
Ba't kailangan po pala ng fractionating column?
Siya yung kailangan mong, ammonia lang dapat ang makalusot dyan.
Di ba po puwede
Okay.
ng ibang ano po, para mas simple?
Hindi naman, as much as possible, you want only ammonia to be, there 'no. So, at least yung ibang substances mata-trap diyan sa fractionating column mo and then ammonia will, pass through. So ngayon, ayan, so the resulting mixture is made basic and then the liberated ammonia is distilled off, collected in what? Ngayon magko-condense yung ammonia mo, Josh. Saan ngayon babagsak yung ammonia mo?
Sa flask po.
Ha? Sa flask o sa receiving flask. And your receiving flask contains what?
Ammonia.
Uy, hindi. Tama naman may ammonia, babagsak siya, eh. Pero anong meron prior sa pagdating ni ammonia?
Oh,
Yung receiving flask mo
acid,
is
acid
also
yata
a
po, acid,
again? Okay, good.
acid.
A trap solution. Actually, it's a trap solution 'no, containing acid because 'di ba ammonia ang, kino-collect mo 'no, so siyempre ammonia basic 'yan. So collect it using an acid trap solution. So usually your acid trap solution there is boric acid, pero pwede din namang other acids like HCl, diluted HCl, HNO3, etc. So Keldal is an indirect titration method. So actually this is where we end. This is where we ended last time, no? So Keldal analysis. Tapos sinolve din natin ito. Ayan, ako nag-solve nito ha last time. So ngayon, if you will notice, ano nga ulit yung kinukuha natin dito, Josh? Percent what? Anong nakukuha?
Nitrogen.
Percent nitrogen. Pero if you will notice, sino yung huling-huling solution mo or form ni nitrogen sa acid trap?
For me, nitrogen.
Kasi from ammonium na-convert into what?
Hmm, na-convert siya into ano po na yung na ammonia tsaka
Ammonia na siya, good.
ammonia
Yeah. Tapos,
ammonium po
from ammonium from acid digestion, ammonium siya. Tapos nung nag-add ka na ng basic solution, strong base, naging ammonia na siya. So, ammonia yung nag-react dun sa acid trap solution mo. So ngayon, yung ammonia, hindi naman kasi siya percent nitrogen, no? Pero madali na lang yan, 1:1 lang naman yan eh. 1 mole of ammonia is equal to 1 mole of nitrogen. However, Josh, paano kapag ah, percent protein ang kailangan mong kunin? Meron ka ngayong factor. Kasi malalaman mo naman 'to sa biochem, we can approximate this 'no. Paano nakuha 'tong mga factors na 'to 'no, 6.25, biochem naman yung sasagot niyan, okay? So parang ganito 'yan, kung ano man yung percent nitrogen na nakuha mo sa Kjeldal analysis, multiply that with a suitable factor for protein determination. We can actually determine the protein in meats, dairy products, cereals, and even wheat flour. Okay? So may factor ka lang dito. Pero kung percent nitrogen lang naman yung hinahanap, okay na yun. Okay? So, ngayon, anong pinaka-solution dito? I'll briefly explain this. Ang gagawin mo lang dito, Josh, is get the total moles of your acid trap solution. For this case, no, for this example, ang acid trap solution natin ay si HCl. Ayan. Kukunin ko yung total nito. Bakit kukunin ko yung total? Kasi gusto kong kunin yung amount of ammonia na nag-react lang dito. Can we directly determine the amount of ammonia that reacted with your acid trap HCl? Kaya ba natin yun, Josh? Directly? Makukuha natin. Kunwari ito lang yung binigay. 25 ml of 0.04977 molar HCl. Ayan yung acid trap mo. Kaya mo na bang makuha yung ammonia na nag-react sa kanya using that information?
I think so.
No.
Why?
Hindi, kasi tignan mo, moles lang yan ni HCl. Saan mo makukuha yung moles ni ammonia? Right? So ngayon, wala kang moles ni ammonia. But we can get the excess HCl. Paano mo makukuha yung excess HCl, Diyos? Sige nga, how can you determine the excess HCl, Josh? So that we can determine the ammonia, no? or yung HCl na nag-react lang talaga dun sa ammonia. Sige nga, Josh. How can you determine the excess HCl? What titration technique must be employed?
Hmm, para ano po, back titration.
Okay, good. Back titration. The back titration will answer our question. Gaano kadami yung excess HCl? So ngayon, di ba may total moles ka na ng HCl or total millimoles. Ima-minus mo ngayon yung millimoles or moles ng excess HCl. Sino yung makukuha mong difference, Josh? Yun ngayon yung moles ni or millimoles ni HCl na nag-react lang kay ammonia. And then relate that to ammonia, then relate that to nitrogen, you'll have the percent nitrogen. I already solved this one last time, then it's time for you to solve this one. So mas mahaba-haba siya. Like what I mentioned, Joshua, ang analytical chemistry ay mahaba talaga yung mga problems. Pero you need to sort out things here, yung mga information and data that you need to solve or get. No? May copy ka nito dun sa handouts natin, if I'm not mistaken. Pero para mabilis din, you can just screenshot this one and then share your screen.
An egg lover student. Okay.
Ayan, sige. Screenshot mo muna.
Okay.
Okay na? Okay,
Opo.
good. So I'll stop sharing ha. And then, you share your whiteboard. Before you share your whiteboard pala, Josh, you try to stop the recording and check. Ay, kaso naman ko-convert pa to, no?
Opo.
Sige, okay lang. Mga 30 minutes naman na eh. Sige, so definitely Keldal ang gagamitin niya. So he chose Keldal method for protein determination. A 0.09820 gram egg sample was digested with concentrated nitric acid in a Keldal flask at 373 degrees Celsius. So this time, aside from sulfuric acid, like what I mentioned, no, you can also use concentrated nitric acid in Keldal analysis. So, mataas yung temperature, no? 373 degrees Celsius. And then the liberated ammonium ions were then converted to ammonia by adding concentrated sodium hydroxide. So the volatile ammonia then condensed and trapped in a 25 ml of 0.01435 molar sulfuric acid solution. This time, yung sulfuric acid mo, siya yung ginawa mong acid trap solution. So please take note, ang sulfuric acid ay H2SO4. So ano ang ratio, Josh, for this? Ammonia and sulfuric acid. What's the stoichiometric ratio for this? Yes, Josh, ano ang stoichiometric coefficient or stoichiometric ratio for sulfuric acid and ammonia?
Ah,
Hina-highlight ko na siya para hindi ka magkamali later.
Wala pong H. So, 2.
Good. So, 1 sulfuric acid, 2 moles of ammonia. So, yeah. And then, the excess, of course, we know that excess yung sulfuric acid kasi siya yung acid trap mo, right? That's the principle, basic principle of um, Keldan. So the excess sulfuric acid was then back titrated with 37.09 ml of 0.007777 molar sodium hydroxide. So assuming that both acidic hydrogens of sulfuric acid are neutralized, calculate the percent protein in the egg sample. So please take note that the usual percent of nitrogen in eggs and meat is 6.25%. No? So to determine the percent protein, from percent nitrogen, multiply this factor lang. So, Keldal and nitrogen factor for meat and eggs. Okay? So, I'll stop sharing and you may now start sharing your screen. Okay, go ahead, Josh. And you may open your camera so that I can see you.
Ilan mo?
Sige. Ayan, sige. Ayan, kita na ulit kita. Then, you may now start solving your or showing your solution for Keldal.
Ilan mo? Check ko lang
Okay
po
lang,
yung
Josh, nandito lang naman ako.
let me check the screenshots.
Okay, go ahead.
Bagal. Mhm.
Please tell me if you're done ha. May kita. Actually, may kita ako naman.
Opo.
Okay, are you done, Josh?
Mhm.
Okey lang po. Ano po siya, working file naman po yun. Pagka bago ka kayo sa plan, sa CR po yung actually.
Ayun.
Teka, hindi naman makaubos na yun. Hindi. Ay, dito? Pumapok dito? Ah, talaga. Malalim naman po yung CR. Kaya okey lang. Sa CR lang talaga. Tapos biglang maglulubog yung weather. Sa boundary. Hindi. Ay, hindi. Sa pinaka sa ano lang po, dun sa pag sa akin din sa pag nalilito. Yes po. Dun lang po. And what is that?
Nitric acid, okey. So, hindi naman nag-ano na.
Yeah, not ano, is that necessary? Yun yung ano mo, digestion acid.
Yung ano, hmm, hmm. plus 0.10. 0. That's point, um,
Okay, you done, Josh? Okay.
alam mo. So, ano na,
Mhm. That's your acid trap. Total most of your sulfuric acid trap solution. Then nag-back titrate ka dyan. Make sure that you will also follow the stoichiometric ratio or take note of the stoichiometric ratio for your sulfuric acid and your back titrant.
nice na po, nice molarity.
Okay na, Josh? What's that 0.28844? I don't know what's that. Make sure that you indicate the correct units, Josh, ha?
So, because there are 2 molars, okay. Hmm. No, 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 it makes sense.
Oy, take note, Josh, if it's moles or mini moles, ha?
Oo, millimoles pala. Tang, 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 tang. Hmm. Okay. So, therefore, millimole pala 'to. Okay, basta. Mhm. Paano na 'to? So, H2SO4, dalawa, divided by 2 times 2. Hmm, okey, 2 for what? Tama. So, na-confuse na ako. Anyway, equivalent lang po 'to sa mole N na po 'to.
Mhm. Make sure it's millimoles, for all throughout. And make sure you've already incorporated um, the proper stoichiometric ratio.
Opo. So, ano gagawin ko lang po siyang grams N.
Mhm.
Nitrogen. Saan na ba siya? 28.02. Okay.
So
Mhm.
nitrogen only, not N2 gas.
Wala, divided by 2 na lang muna. Ayun.
Mhm.
So, mga 6.011. Okay. Divided by 0.09820 times 100. So, that's 0.12%.
Uh-huh.
And ano, what's the ano daw? 6.25. Okay, so it makes sense. Tama mo. Tama siguro mo. Hmm,
What's your answer, Josh? I need to see the percent nitrogen and percent protein.
kailangan mo ng ano, percent mo wait lang.
Hmm.
Hmm.
Percent N ang hinahanap natin. Actually, I'm looking for the percent protein. Calculate the percent protein in the example. So your factor here is 6.25. Ano, nag-convert na yung ano, nauna nating video?
Na ano mo, na-convert?
Mm.
I think so.
Yeah, you may now check if it's only 10 minutes lang or 5 minutes. Supposedly it's around 30 minutes or more. Yes, Josh?
Mhm. So yung ano, saan napunta? Wait lang mo.
Mhm.
Paano ko po malalaman pala yung ano, yung protein? Mhm.
May multiplier ka, may factor, suitable factor ka.
So, remove 'to. Huh? So, 6.25. Ano po, anong
Mhm.
percentage ng protein? So, dapat 6.12 over, 6.25? Mga
Times yan. Ito times mo siya. Kasi factor nga siya eh.
118, 6854. Okay.
And your answer is what?
Wait. So, nasa usual percent naman lang po of Saan yung percent po sa Meron po sinabi?
Yeah, oo. Nasa problem siya. The usual percent of nitrogen in the eggs and meat is, I mean, yan yung factor mo. Yan o, Kjeldahl nitrogen factor for meat and eggs. I mean, factor siya, hindi yan yung usual percent. I mean, dapat ang nakalagay niyo sa problem, usual factor for the percent of nitrogen in 4% proteins in meats and eggs. Dapat ganun yan. Mali lang yung ano. Pero factor yan, factor siya. Yes, Josh, what's your percent protein? I'm looking for the percent protein, not percent nitrogen.
So, paano ko po malaman actually yung percent protein?
You just multiply that to the factor, to the given factor.
Yun lang?
Yun lang yun.
5%?
Mm.
So, mga 0.382%.
Again, what's your answer?
Point 382?
No. 6.12, multiply that to the given factor.
Times 6.25%.
And your answer is?
0.382.
Anong 0.8? No, hindi siya. I mean, that's direct na siya. Kasi naka-percentage lang din yan eh. Sorry, times 6.25 na siya. Direct. Straight na siya.
38.2 mo.
Ayan. So, the answer is 38.25 or 38 point, I think 4. We need to report 4 sig pig. Except sa data mo kasi, di ba parang ang nakalagay ang data natin dito sa temperature, 373 degrees Celsius, 3 sig pig lang. You don't need to use the degree Celsius kasi it's not included in the calculation per se. So, we'll only have 4 sig fig. And also, the 6.25 as a factor doesn't need to have 4 sig fig din. So, or you don't need to follow it sig fig, no? Baka sabihin mo, sir, 6.25 is 3 sig fig. No. Ano naman siya? That's correct. The answer is 38.25% nitrogen. So I'll stop sharing lang and then I'll share my screen. Screen ko siguro. Ayan. Okay, good. Josh, anong nakikita mo, Josh? Yung
Yung
problem itself?
opo.
Okay. Dapat ito yun eh. Control X. Ayan, dapat ganyan siya. Yan siya. The Kelvin nitrogen factor for meat and eggs is 26.25. Okay. So, ayan, nagpalit na rin siya. Anyways, ayan. So, we're good with the Keldal analysis, no? So, please remember, Joshua, ang Keldal ay ginagamit natin for nitrogen determination. It has 3 stages. The first stage is, nga ito. The first stage is, asan na siya? Ayan. The first stage is acid digestion, usually using sulfuric acid, followed by the neutralization of strong base, sodium hydroxide and KOH. No? From acid digestion, you have ammonium ions, and then ammonium ions will be converted to ammonia once you add a strong base, and then your ammonia will be distilled and collected in an acid trap solution. So your acid trap solution is usually diluted acids like boric acid, hydrochloric acid, etc. And then from the acid trap solution, that's your preliminary reaction, the excess of your acid trap solution can be determined through back titration. That's the reason why we perform here back titration. So sa back titration mo, lagi yung basic titrant. Kasi nga, ang pinagtatrap mo naman sa ammonia ay acid solution. So therefore, you'll use basic back titrant, no, for the back titration process. Okay. So another incomplete tuloy. Indirect titration, Josh, is example of this one. So hindi ito Kjeldal, pero if you will notice, indirect titration is very flexible in such a way we can also determine other organic substances. Example nito, determining organic and biochemical substances using indirect titration. So I'll read the problem, Josh, and then you'll solve this one again. 0.8160 gram. This time, I'll guide you na para we can proceed sa next topic natin. 0.8160 gram sample of dimethyl phthalate. So, the formula of dimethyl phthalate is given in its molar mass. We're fortunate that the molar mass is already given. 194.19 grams per mole. And unreactive species, so however meron kang unreactive species, no, was reflux with 50 ml of 0.1031 molar NaOH to hydrolyze the ester groups of your dimethyl phthalate. If we will see the reaction, uh, for every mole of dimethyl phthalate, you'll require 2 moles of your sodium hydroxide or hydroxide ions to produce dimethyl phthalate ion and what's the byproduct, Josh? Sige nga. Sa pag organic tayo, ipapakita mo yung mechanism sa akin yan eh. Pero hindi naman tayo organic. Pero if you will notice, you form what? Dimethyl phthalate ion nga, or carboxylate, no? And what's your byproduct? Yes, Josh, anong byproduct mo?
Para saan na po? Byproduct is methanol.
Yep, methanol. So, if you will notice, ano nangyari dun sa, can you try to, to propose a structure for COOCH3? Ano yan? COOCH3. Sige, drawing ka na lang din dyan. You try to annotate. Yung COOCH3 lang ang need ko makita, Josh.
Mhm. C8 COOCH.
COOCH3, oo.
So that's like ano ba? COOCH.
Mhm.
Mhm. Ayun.
Ayan, ganyan 'yan, correct 'no. So that's your, anong group 'yan? Anong functionality? Kasi magkakaroon ka ng idea, eh, kung anong reaction yung nangyari. Anong functionality 'yan, Josh? 'Yan oh, C double bond O-O-R, parang R, may R ka group, may R group ka diyan, yung C6H4 mo, that's your first R group, and then your second R group is metal. So, in fact, ano 'yan, naka-ortho position 'yan na, benzene ring. So, yan. Meron ka ditong benzene ring, okay? Yan. Then you also have another, COOCH3 form. Yan. And then OCH3. Anong ano 'to, anong functionality 'to, Josh? So, anong functionality si dimethyl phthalate? Oh, yes, Josh, anong functional group 'yan? Uy, identification lang 'yan ng functional group.
Ano yung ano mo? Which one? Ito mo? Is
Mhm, yeah. Correct, it's an ester. So, esterification 'yan, eh, de-esterification nga, eh, 'no. So, during de-esterification natatanggal yung R group mo dun sa naka-attach kay O. So, kaya nagiging carboxylate siya. And then you will produce yung CH3 mo diyan na nakakabit kay O, magre-react kay OH minus to form methanol. Okay, of course we have a mechanism there, ituturo yan sa organic chemistry 'no, not here in, um analytical chemistry. Kaya dapat familiar ka din, Josh, ha, if you will notice, organic ang reaction. Kaya dapat familiar ka din sa organic reactions kasi minsan hindi yan binibigay. Like sasabihin lang nila meron kang dimethyl phthalate and then ni-react mo siya sa sodium hydroxide. So automatic, esterification process kasi ang mangyayari diyan. So matatanggal yung methyl group mo dun sa esters mo to form 2 moles of methanol. And the ratio is for every mole of dimethyl phthalate you need to use 2 moles of sodium hydroxide or hydroxide ion. So, ngayon ano daw yung nangyari, 'di ba? So, kasi may unreactive species ka, Josh, eh, 'no? So, 50 ml, 0.31 molar sodium hydroxide, yun yung preliminary reaction mo. So, uubusin mo muna lahat ng dimethyl phthalate. Ngayon, we're sure here that the sodium hydroxide is in excess. So, siya yung excess mo ngayon, no? So, after the reaction was complete, the excess sodium hydroxide was then back titrated with 24.27 ml of 0.1644 molar HCl. So, I need you to get the percentage of dimethyl phthalate in this sample. Sige, go ahead, Josh. Pwedeng dito ka na rin mismo mag-solve, Josh, kung gusto mo. Sige, I'll give you, siguro 5 minutes, kaya mo na yan. Yes, Josh, dali, para at least ano, may meeting din kasi ako around 5 o'clock, pero dahil nag-start tayo around 5:10,
Abo.
5:10 to 5:15 tayo end. Para we can go sa next topic natin, which is titration curve.
Abo. So, percentage. Mhm.
So, sino yung in excess mo? Kunin mo na kaagad yun, yun yung para mabilis tayo. Sino yung
N
in excess?
NaOH.
Okay, good. Get the millimoles of NaOH. Then sulat mo dyan.
Nga mo.
So, ilan ang millimoles mo? Yung total muna.
Very sad po kung parang isipin na po parang yung pagka-renown. 3.98988. Hmm.
Okay. So, yan yung ano yan, excess or ano?
Hindi po yung ginamit na yung na-backtitrate na excess.
Yeah, yan yung excess na millimoles NaOH, right?
Opo.
Mhm. So, ano yung total millimoles mo ni NaOH? Okay. So, ngayon ano ang gaano kadaming NaOH yung nagamit mo? Okay. So, good. Ngayon, ilang dimethyl phthalate, millimoles si dimethyl phthalate ang present?
Nilamosan dimethyl phthalate.
Yeah, kasi siya naman ang nag-react sa NaOH mo, eh.
Hmm, so gano'n naman so
1:2 sila, Josh.
1:2.
1:2.
So I need
Mm.
to multiply by 2 only.
You need to multiply by 2 or you need to divide by 2?
Ang divide by 2 kasi OH yung ginamit ko na. So divide by 2.
Okay, good. Kasi meron ka ng 1.16512 millimoles NaOH. So, you need to convert that to millimoles of dimethyl phthalate. So, divide that by 2 kasi 1:2 ang
Ano
ratio
po yung
nila, eh.
molar mass? Ano po yung molar mass?
Ang molar mass ay binigay 194.19. Ayun, no? Ay, basahin mo yung problem. Ay, isulat mo muna yung yung millimoles ni dimethyl phthalate. Ilagay mo sa formula niya dun sa reaction mo. -9 talaga na moles?
4.
-4, okay. Okay. Okay, correct naman. Tapos, ilan yung grams ni dimethyl phthalate na present?
So mga 0.11. So mga ano po 'to,
Okay,
30.
good. Then, i-divide mo yan ngayon sa ah, total mass mo. So, the percentage is, okay, very good. 13.86% dimethyl phthalate is present in your original sample. Okay? Joshua, yung mga techniques na ito, wag mo 'tong kakalimutan ha, because the back titration, indirect titration, these are titration techniques and we will be using them or employing them in the different titrations that we will see later. Kasi acid-base pa lang ito, pero hindi porket acid-base sila lang ang nagba-back titrate or indirect, no. Even sa complexometric titration, nagba-back titrate ka tsaka nag-indirect ka. Even sa precipitation titration, you can also use direct titration or back titration. And even sa redox, no? Redox reaction also have this back titration or indirect titration as techniques, no? Titration techniques kasi ito. That's the reason why I started with them. Sa ibang books kasi, hindi mo makikita kagad yan sila indirect and direct titration. Minsan, nasa ibang chapters pa siya, naka-integrate siya. Eh, eto kasi if you will notice paulit-ulit yan like you'll have direct, indirect 'no, tsaka yung, displacement and even yung indirect titration, I introduce it earlier. So that when we will go to complexometry, precipitation, redox, and eto kita natin sa acid-base, you still have them direct and, indirect and displacement titrations. These are titration techniques, okay? So ngayon, let's now proceed with the titration curve. Okay, wait, let me do the annotation and then clear all drawings ko lang ha, para clear tayo. Yeah. Okay. So, what is a titration curve? Later, baka ibigay ko sa yung assignment itong paggawa ng titration curve, no? So, when you say titration curve, this is a plot of some property of the titration mixture that changes as the reaction progresses. So, parang as you proceed with the titration, anong nangyayari dun sa isang property ng titration mixture mo, no? So, ngayon, usually, ano yung ginagamit nating property? Sige nga, do you have any idea, Josh? Sino yung nagbabagong property ng titration mixture as you add the titrant for acid-base, kunwari acid-base titrations, Josh, anong property ni mixture, titration mixture ang nagbabago as you add the titrant? Kunwari
Titration.
ang sample mo or analyte mo acid, ang dinadagdag mong titrant base. Anong nagbabago dun sa mismong titration mixture mo habang nagdadagdag ka ng base sa isang acid na sa analyte? Sige nga, anong possible parameter ang magbabago? O ulit, may acid ka na analyte, nagdadagdag ka ng base incrementally or slowly. So ano kaya ang parameter na nagbabago or property nung mismong mixture mo?
Wait lang po. So, ano na? Mhm.
Sige, go ahead, ano?
Yung nag-iiba nag-aano ng ano, yung
Kunwari
K
nagdadagdag ka ng
K
yung
yung KA mo,
Ka, Ka ay nagbabago?
pH.
pH, ang Ka hindi nagbabago Diyos unless baguhin mo yung temperature, dun magbabago ang Ka. Pero ang Ka ay once you have consistent or constant temperature, hindi siya magbabago. Let's say anong ulit ang Ka ng acetic acid mo, naalala mo?
Parang asin mo sa muna po na per kb.
Same with ammonia sa Kb. 1.75 times 10 to the negative 5. Wag mo nang kalimutan yan kasi usual yan. 1.75 times 10 to the negative 5. That's the
So,
Ka for
so
acetic
technically
acid.
I can drink vinegar and ammonia. Tapusan walang mangyayari.
Technically, yes. Kaso lang siyempre hindi sila the same ng concentration. You need to consider the concentration as well. Okay?
Opo.
So, anyway, ngayon, paano mo naman made-determine yung reaction progress sa titration? Ano yung nag-i-indicate na nagpo-proceed yung reaction?
Yung indicator.
Hindi. Tama nga naman. Pero ang indicator, siya yung nagsasabi na tapos na yung reaction. Pero how can you know that the reaction is progressing?
Meron ba?
Ano ba
Well,
yung
ako,
dinadagdag mo incrementally?
yung base.
Yung titrant. Pero
Like,
anong property ni titrant ang dinadagdag mo?
mm,
Sige, ano nangyayari habang pumapatak yung titrant dun sa titration mixture?
nagre-react nga po siya.
Nagre-react, so nagbabago ang pH and nagbabago din
Kulay.
ang
Yung kulay ba?
color kasi may indicator. Ano pa?
Ano pa? Taste?
Very basic, ha?
Taste po.
Hindi.
Ano kaya? Ano
Ano
kasi?
nangyayari sa level?
Tumataas. Kung tumataas,
Ano yung nagbabago?
volume. Volume.
Volume. Ngayon, yung volume mo, siya yung nag-i-indicate na nagkakaroon din ng reaction progress. Okay? So ngayon, ipa-plot mo siya. Ipa-plot mo ngayon siya. Sino ang independent volume mo, Josh? Ay, independent volume. Independent parameter sa titration. Ibig
Volume.
sabihin, control mo ito. Volume, kasi di ba, increments yun.
Naka-computer
So,
po
nakokontrol mo pa rin siya.
paano po sila? Dropwise.
Dropwise. So, saan mo siya ilalagay kapag graph? Ayan, tinuruan na kita nito sa lab. Nasaan siya? X or Y axis?
Yung saan mo?
Independent parameter.
Wala.
Independent variable. Nasaan? Nasaan yan? X or Y?
Y-axis.
Nasa?
Y-axis mo.
Okay, ang tamang sagot ay X.
Tama.
So, ibig sabihin, nasa X-axis mo, ayan, magdo-drawing ako, yung volume mo. So, this is volume. Ngayon, ano ang nagbabago? So, depending sa volume, nagbabago ang
Yung ano naman, tawag nun, depende sa volume.
volume to. Actually, volume to ng titrant eh. Kasi di ba yung sa umpisa, zero ang titrant mo because you don't have titrant eh. And then incrementally, nagdadagdag ka ng titrant. Let's
Volume.
say, 5 ml, tapos magiging 10 ml. So, ano ngayon yung magbabagong parameter habang nagdadagdag ka ng titrant?
pH.
Very good. pH ngayon yung magiging, y-axis mo. Tapos alam mo kung ano yung itsura nung curve? Do you have an idea? Siyempre
Wait
dapat
lang
may
po.
idea
So
ka na.
so kung biglang magkaka-equivalence point, gano'n nga mo, parang gano'n. Yung
Hmm?
may
Anong parang
equivalent
gano'n? Sige, try mo
gano'n sa
mag-drawing. Yan, try mo mag-annotate diyan.
or something.
Wow! Okay, dahan-dahan 'no, dahan-dahan yung pag-angat, kasi volume mo ay ang titrant mo ay base
Ayun,
'no?
ganito. Parang gano'n, oo.
Ayan, ganyan. Titrant mo ay base kaya dapat aangat siya. Paano kapag ang titrant acid analyte ay ang analyte mo ay base?
Gano'n mo,
Very good, pabaliktad siya. Yan yung tinatawag nating sigmoidal curve. Ayan.
sigmoid. Baka sigmus? Merong mga sigs may ano ano po yan?
Kasi hindi ko alam, sa math kasi 'to, math term 'to, eh. Applicable lang naman siya sa chem 'no, so parang ginagamit lang ni chem yung mga mathematical terms. So sigmoidal curve ang tawag diyaan sa math. Oh, wait lang, 'yan para maliwanag lang 'to. Sigmoidal curve 'yan. So a sigmoidal curve is para hindi mo makalimutan letter S ang sigmoidal, letter S din yung itsura niya 'no. So sigmoidal curve siya. So it's a P function of your analyte. Usually kapag acid-base, Josh, tignan mo ha, P function ito. When you say P function, ano nga meaning ulit ng P?
Yung ano nga po, negative lang.
Very good. So, kung ang P function ko ay pH, that's a negative log of H, no? So, kasi pwede mo siyang baguhin. Pwede yung P calcium, P magnesium. So, kapag mga ano yan, complexometric o kaya precipitation titrimetry, pwede rin magbago yan depende sa kina-calculate mo, no? For the for the redox, pwedeng magbago din yan. Hindi pH na yung mine-measure natin. Okay? And then we are plotting it against the titrant's volume, no? So kung ano man yung volume ni titrant, yan yung magiging reaction progress mo din. So kaya siya yung nasa x-axis. Ngayon, if you will notice, meron ka ditong tinatawag na, anong tawag dito, Josh? Where in the direction of your graph is changing. Ayan o, yung part na yan. Naalala mo yan sa math? Anong tawag mo dyan? Yung
Saan po?
nagbabago yung slope. Ha?
Ano nagbabago po ng slope?
'Di ba, tingnan mo parang parallel lines ito, eh, supposed to be, eh. Pero pinagdugtong mo siya, so nagbago yung slope niyan. Anong tawag sa point na 'yan?
Equivalence point.
Sa ano 'yan, sa chemistry 'yan, kasi
Wala
nagta-titrate
po
tayo, eh.
wala po ako
Pero
na-enter.
sa curve na 'to, anong tawag diyaan?
Ah,
'Di ba
ah,
sigmoidal curve ito, kasi sa math sigmoidal curve 'yan, eh.
inflection, point of
Very
inflection.
good, inflection point siya or point of inflection, tama
Opo,
'yun. Nice. Ayan, inflection point ito. Inflection point, yan. Or point of inflection, okay lang yun. So that's your inflection point. Okay? So, very important to Diyos siya kasi parang alam mo lahat ng nag-anak kayo ng estudyante, alam na alam nila 'to or naranasan dapat nila yung paggawa ng titration curve. Mga nakakaiyak na topic ito kapag sa mga estudyante kasi ang daming kino-compute. Anyway, dito mamaya gusto ko makapag-create ka din ng let's say sa Excel na lang o kaya kung gusto mong program to create a titration curve. So anyway, yan yung mga basic ideas natin for the sigmoidal curve. We will learn about sigmoidal curves pa no sa mga previous slide at sa mga next slides. Let's go now sa second type ng titration curve. We also have linear segment curve, no? So by the way, the inflection point also represents your equivalence point. So, basta tandaan mo yan, yung mismong inflection point mo, siya yung equivalence point mo. So when you say inflection point, this is the point wherein, literally sa math, no? Sa graph, inflection point, this is where your slope changes. No? So nagbabago yung direction ng linya, nagbabago yung slope. So sa inflection point yan. Okay? So, ngayon we also have another form ng titration curve. It's known as the linear segment curve. Bakit siya linear? Kasi parehas lang din lines, no? Tapos parang may nag-intersect lang na lines, no? Dito sa ating curve. So, ngayon, anong nangyayari dito? So, measurements are made on both sides of but well away from the equivalence point. So, we're actually not getting the real equivalence point here, no? Yung real value
Opo.
nung equivalence point. So, kasi nga, i-extrapolate lang natin yan later eh. No? So, when you say the word extrapolation, you have a line, technically curve siya. So, gusto mo siyang i-extend, gagawin mong line lang, linear yung behavior. So that you can get that point, no? So yung equivalence point mo dito, technically hindi mo siya nakukuha kapag ginagawa mo yung experiment. Kasi when you're doing a linear segment curve, no? Kasi nga hindi mo naman talaga siya nadadaanan. Okay? So the vertical axis represents an instrument reading. This time it's not pH anymore, no? Usually it's an instrument reading or response. Ang term natin dito, instrument reading or instrument response, no? Which is directly proportional to the concentration of your analyte, no? What's your x-axis, Josh? Titration pa rin ito, ha? Anong x-axis mo? If you have linear segment curve, Josh.
Ano po siya natagdan yung volume pa rin.
Very good. It's still volume. And what can you say about the lines? Ito, tingnan mo yung curve, Josh. Di ba, parang siyang two
Wala.
lines. Oo. Parang two lines. However, nakuha mo ba talaga yung mismong equivalence point or nadaanan mo siya sa experiment? Ayan, no, ito yung equivalence point eh. Naglalay ba siya dun sa graph?
Hindi po, pero nandun siya sa
Hindi.
yung x-axis na nag-ano.
Oo. Yung extrapolated. Yun yung term natin na extrapolated. Yung dalawa mong lines, hindi naman talaga sila nagmi-meet eh. Kasi kumurba yan eh. Ngayon, i-extrapolate mo yung two lines with different slopes. Ito yung sinasabi ko sa'yo. Inflection point din yan. Kasi dito nagbago yung slope, no? So, yung pinaka-extrapolation point nila wherein the two lines will meet, that will be your equivalence point.
Ah, okay.
Okay? So, ayan yung equivalence value mo.
Is it even more ano
Hmm.
tawag
More
accurate yan?
correct?
Kasi yung ano po medyo
Mhm.
eyeball yung ano sa sigmoidal curve.
Mhm. Kung ako 'to ha, when it comes to accuracy, accurate pa rin naman ang sigmoidal curve. Pero when it comes to sensitivity, linear segment curve ang ginagamit natin. Kasi sa instruments mo ay sensitive eh, highly sensitive na mga instruments 'no. So,
No,
remember niyo siya, accuracy and sensitivity, they are different. Ang mga titration curves kasi na sigmoidal usually for acid-base, yung ano talaga siya, wet lab kumbaga. Though
opo.
wet lab din naman 'tong linear segment curve 'no. So, when you say wet lab, we don't use sophisticated instruments for sigmoidal curve to be generated. Kasi ano lang yan eh, acid-base, yung usual, complexometric, precipitation, redox, gagamit ka pa rin ng sigmoidal curve. So, however, if you will notice there, mas malaki yung error nila kumpara sa linear segment curve wherein your linear segment curve depends on the instrument's response or instrument reading. Ang malaking tsansa mo lang magkamali kay linear segment curve kapag yung instrument mo palpak. How can you correct the instrument? Sige nga. O
By
napag-aralan
by
na natin
buying
yan,
a
Josh.
new one, calibrating or repairing.
Not buying a new one, that will be too expensive. You will give
Ano
headaches to the
ano
owner.
ano po, sir, the lab does not work. Please can I buy
Yeah, at saka imaginin mo, what if you owns the lab or what if you're the head of the project? You'll be giving headaches to yourself if your solution is always buy a new instrument. Okay? You do calibration lang. Okay, as much as possible, calibrate it or find um work ways, no? Or what do you call this? Uh, find a way wherein we can work around natin so that we can have a proper instrument response or instrument reading. Okay? Good bit. Let's now move on with the sigmoidal curve. Like what I mentioned, Josh, no? Sa sigmoidal curve muna tayo magfo-focus because we're doing classical, it's a classical technique. Titration is actually a classical technique, no? Yung linear segment curve, parang combo yan eh, ng classical and instrument. Kasi may instrument ka, but you're still generating sigmoidal curve, no? So, yeah. So the general shape of a titration curve for acid base or the usual classical titrations will be sigmoidal curve or the S curve. It consists of two lines that are parallel to one another. If you will notice, Josh, tingnan mo to. Ito yung sinasabi ko sa'yo kanina. Oh, you listen very well, ha? Kasi i-generate mo to. So, if you will notice, ayan, ito yung una mong line, e-extrapolate ko kunwari, then ito yung second line mo. And what can you say about the two lines here? Ayan. What can you say about the two lines, Josh?
Parang medyo parallel sila.
Yeah, oo. Parang actually parang lang naman kasi yan, 'no? Pero actually parallel yan talaga sila, 'no? When we do sa mathematics or sa programs o kaya sa Excel natin, talaga makikita mo parallel lines yan. If we will extrapolate. However, sa S-curve naman ay meron kang inflection point na tinatawag. So, yung inflection point, that connects your two parallel lines, no? So, yep. So, ngayon, yung two parallel lines will be parang intersected or intercepted by this line, no? Ang tawag natin ngayon doon, Josh, ay pH break. The pH break also contains the inflection point, wherein your inflection point is also your equivalence point. Okay? So, anong tawag ulit dito, Josh? Yung sa naghihiwalay dun sa dalawang lines, dalawang parallel lines mo? Ng titration curve. Ang tawag natin ay,
Mhm.
what do you call that? That's your, hmm,
Equivalence point lang.
oh, hindi equivalence point yan.
Lang.
What do you call that line?
Yung sigmoidal curve.
Sigmoidal curve siya. Di ba yung sigmoidal curve mo may parang two parallel lines and they are connected by what line or by what portion? We call that the pH transition range or the pH break. Yun yung inaano natin yan. pH break yung tawag natin dyan. Okay? So ngayon, the pH break also contains your inflection point. So ano ba yung meaning ng inflection point? So the inflection point is your equivalence point. So please take note, Josh, ha? Okay, I'm discussing the basics of titration curves, Josh. You listen very well. So the number of inflection points or steep portions, kumbaga, ng iyong sigmoidal curve represent the stoichiometric ratio between the analyte and titan. If you will notice for the left graph or left illustration, Josh, how many inflection points do you have?
Mhm. So, dito po ay sa 1, 2, 3, 4.
Sa left.
Sa left 1.
Okay, one. So, anong ratio ng analyte and titrant mo? Isa lang
Hmm,
inflection point eh.
baka isa lang po yung alangan niya.
So, what's the ratio? I'm asking for the ratio.
Ratio 1:1.
1:1. Sino ang 1? Sino ang sa image, Josh, sino ang analyte, sino ang titrant? Is your analyte acidic or basic? Sino ang titrant mo? Analyte, ang titrant mo, acidic or basic?
Parang
Sa
ano yan,
left, left.
acidic po.
Acidic sino?
Yung titrant.
Paano naging acidic ang titrant sa left?
Ayun eh, mababa pala po yung pH na. So,
So, nag-start ka sa mababang pH. Ibig sabihin, ang
basic
analyte mo yung
titrant.
acidic. Ang titrant mo, basic. Basic ang titrant mo. Kasi
No,
tignan mo yung x-axis mo, Josh. You're adding titrant and what happens to your pH habang nag-add ka ng titrant? As you add your titrant, what happens to your pH, Josh?
mhm. Tapos tumataas po yung pH.
So therefore, your titrant is what? Acidic or basic?
Acidic or titrant was basic.
Basic. Ngayon, tignan mo ngayon ha, 1:1 yan, walang problem yan kasi 1 acidic analyte is to 1 mole basic titrant. Paano yung kabila? yung right. How many inflection points do you see? Sige nga. How many inflection points do you see for the right one?
Mhm.
Hmm.
Mga 4 yata po na.
Bakit naging 4? Bilagyan mo ng asterisk yung mga inflection points. Okay, 1, 2, 3, 4. Okay? So, hindi puwede yung A, hindi kasama yung A.
I don't think so.
Okay, alam mo ang tamang sagot? Dalawa lang ang inflection points.
What?
Si letter C and si E lang. Hindi naman at letter B and D, hindi naman nagbabago ang slope ng line mo diyan, eh. I mean yung direction ng line mo is going downward pa rin naman. Pero if you will notice, si C and E, iba ang direction ng lines nila. So kung parang pa ganun yung, iba, pababa naman yung parang mga bangin 'no. Steep nga, eh, yung steep portion. So si C and E lang ang steep portion mo diyan. That will be your inflection points. Okay, babalik ako dito. What happens to your pH as you add your titrant?
Bumababa po siya.
So what is your titrant? Anong nature ng titrant mo? Acidic or basic?
Basic. Ay hindi, acidic yung titrant tapos ang basic yung ano na.
Analyte. Okay, or yung sample mo, very good. Ang sample mo ay basic kasi mataas ng start eh. Tapos habang nagdadagdag ka ng titrant, nagiging bumababa yung pH. So therefore, acidic ang titrant mo ngayon. Ngayon, may question ako, Josh. Ano ang ratio nila? Sige nga. Anong ratio nila? Sino
Re
ang 1? Sino ang kung ano man yung ratio mo? So again, the number of inflection points indicate the stoichiometric ratio between your analyte and titrant. So how many inflection points do you see?
1:2.
1:2. Sino ang 1? Yung titrant or yung analyte? And sino yung analyte mo ulit? Yung analyte mo ay basic. Basic analyte. And yung titrant mo, acidic analyte. Sino ang 1? Sino ang 2?
Acidic yata po yung 2. Acidic yata po yung 2.
2 acidic titrant is to 1 basic analyte. Tama ba ako?
Opo.
Bakit 1 si basic analyte?
Mhm.
Hmm. Sige, bakit 1 si basic analyte?
Hindi ko po alam. Actually.
Okay. So, in fact, kasi tignan mo nga, ang nangyayari dito, Josh, ang analyte mo ay si base, no? What happens to your base habang nag-a-add ka ng acid? Bumababa yung pH. At kada inflection point yan, Josh, ibig sabihin, completely natatanggal yung either H or OH when it comes to acid or base na analyte, no? So, dahil base ang basic analyte 'to, OH completely ang natatanggal. So, ang tamang sagot diyan siya, since may dalawa tayong inflection points, meron kang 2 moles ng OH in fact, no? So, this is 2 moles base and 1 mole acidic titrant. Wag kang mag-alala, iisa-isahin natin 'yan kasi titingnan natin yung species by species diyan, eh. So, puwedeng ganito 'yan, titration ito ng magnesium hydroxide o kaya ng barium hydroxide or any alkaline earth metal hydroxide. So, beryllium hydroxide, magnesium hydroxide, calcium hydroxide, puwedeng ganyan 'yan. Ganyan ang titration curve nila. Pababa at tapos dalawang inflection points. No? So, don't worry, like what I mentioned, iisa-isahin natin talaga yung mga points niyan, Josh. Kasi ang kailangan dito, Josh, ang goal ko dito is, ang objective natin for this topic is for you to generate a titration curve if you're given a titrant and an analyte. That marunong kang gumawa ng titration curve. And of course, you need to explain, no? You know how to explain as well yung titration curve natin. Okay, let's proceed. So, like what I mentioned, Josh, no, the titration, the classical titration technique or classical titrimetric methods, kumbaga, no, can be different, can be classified into 4 lang. So, apat lang yan. So, classical classical titration ito. The number one is, we're discussing it already, the acid-base titration. Okay? So, this will be general types of titration and their titration curves, no? So, acid-base. So, anong itsura ng acid-base? Pag acid-base, Josh, yung drinowing ko kaninang um, titration curve, no? So, volume ni titrant, tapos pH or POH ngayon ang pwede. So, please take note, Josh, no? Hindi lang naman pH yung pwede mong ilagay dyan. So, like what I mentioned, P function yan. So, pag acid-base, madali kasi i-monitor na si OH and H plus nagbabago. OH negative and H plus nagbabago. So you'll have your titration curve. So that's your acid-base titration curve. However, paano pag precipitation? So sa precipitation kasi usually, tingnan mo, anong meaning ng PAG, Josh? Pag.
Mhm, PAG?
Yeah. It's still
P
volume ng
P
titrant.
ano, P of ano, P P of ano, silver.
Very good. Bakit kaya silver yung ginagamit natin? Kasi usually, silver is being used for analysis of
Halides.
the halide.
Halide.
Sino nga ulit yung mga hindi nadi-dissolve sa water using AG? Naalala mo?
Mhm,
Sino
AgCl.
yun? AgCl, chlorides, yung group 1 cation. Sino-sino yung group 1 cations?
Fluoride, chloride, bromide, iodide, acetonide.
Uy, group 1 cations. Ay,
Ay,
sorry,
group
sorry. Yeah, tama. Pwede yun. So, AgCl or AgX. Yung AgX mo, hindi naman yan nadi-dissolve sa tubig. So, you're precipitating it. So, habang nagdadagdag ka ng Ag, dun mo nakakalculate yung pH din, no? So, nagbabago din siya. So, let's say, mababa ang Ag mo talaga sa umpisa kasi wala ka namang Ag, no? Or silver. Pwede ring baliktad yan. Pwede ring PX siya. Ay, asa na yun? Control Z. Hindi pala pwede mag-control Z dito. Yan. Mababa talaga muna sa si PAG and then gaganon din siya. Okay? So, pwede rin namang PX ito. Pag PX, sino yung X mo ngayon, Josh? It's your anion and usually that's a halide. No? Depende kung sino yung piniprecipitate out mo. So, malay mo naman kasi baka ibang halides or ibang anion yung gusto mong i-precipitate. Let's say, phosphate, sulfate, etc. Tapos you're using a different cation to precipitate it. Let's say, Josh, pag phosphate, anong pwede mong gamitin pang precipitate? So, isip ka ng compound na insoluble sa water, tapos phosphate siya.
Mm.
Sige. Iron phosphate, 'di ba? Iron phosphate insoluble yan sa tubig. So if you're adding iron 2 plus or iron 3 plus, definitely your phosphate there will fluctuate or magkakaroon ng changes rather. Hindi siya fluctuating eh. Magkaka-pattern pa rin and then you'll have this titration curve. So we have now acid-base titration and precipitation titration. So far we are discussing already acid-base titration, no? Kaya uunahin natin yan, Josh. Uunahin nating aralin si acid-base titration. So, tsaka yung titration curve niya, pati yung mga applications niya. In fact, ang kasunod na topic natin, Josh, after acid-base titrations, no, which is mahaba-haba pa ito, precipitation titration. So, sa precipitation titration, we will see, no, yung silver titration. Silver usually yan eh. So, kaya nga pag sinasabi ko, itong precipitation titration pang mayaman to na ano eh, na titration technique or titration type, no? Kasi silver ang ginagamit mo na pang-react. Next, the third one is complexometric titration or complex formation titration, no? So ngayon, if you will notice, ganun pa rin yung magiging ano natin, um, titration curve. Volume pa rin ni titrant sa mismong x-axis. But this time, PM na ngayon ang nagbabago. What's PM, Josh? P capital M.
PN? PM?
PM.
P na molar? Hindi kaya?
Hindi M is, may ano naman siya eh. May definition. M is your,
Mhm.
M is your metal cation. So kahit anong
Meron ka
metal
tayo.
yan, let's say pika. So anong meaning ng pika? It's
Pikachu.
not the food. Good. Calcium.
Pikachu.
Okay. So pwede rin yung PMAG, PMG, no? So
Opo.
depende dun sa tinatay-treat mo. Tingin mo, hulaan mo, sino ang pinangtatay-treat mo dito? Sinong titrant mo? Complex formation ito eh, no? So you form a complex here or a coordination compound. Sino kaya ang magandang titrant? May naalala ka pa bang pang-complex sa mga metals? Yung sobrang ganda nung kain niya dun sa mga metals. Clue mo, hexadentate ito na ligand. Hmm, hmm. Naku, sobrang onti lang ng mga hexadentate ligands. Sinong pinakasikat na hexadentate?
Hindi eh.
Again?
Tetradentate pala yun eh. So, ano pala?
Sinong
Hexadentate.
hexadentate? Mm,
Yung ano po na yung sa Kobat, yan.
parang gano'n, yung
Oh, bilang mo.
naka-close siya.
Yung ano,
Chelation 'to, eh.
opo. Meron akong alam, pero yung ano kasi, yung, ano ba?
6 yan, ha, hexadentate yan.
Opo, alam ko nga po yung parang, ganun ka po siya, tapos may ganun. Yung ano,
Ang ED,
hindi mo po siya eta. Hindi mo po siya eta.
EDTA. Actually, EDTA yan.
Ay,
Kaya
tama.
usually
Tama
EDTA
pala.
yan. Volume yan ni EDTA usually. So, si EDTA, very flexible nito na EDTA. Ang galing nga nito na EDTA, ang dami mong metal analysis na kayang i-complex ni EDTA. So, EDTA lang yan. Okay? And then, we also have the last one. So, kaya ganun pa rin yan. Mababa yung, mataas pala rather, yung metal mo sa umpisa. Then, habang nagdadagdag ka ng EDTA, bumababa siya. Okay? Pabawas ng pabawas yung metal mo. And then, finally, we have the electrode potential. So, your redox. So, volume pa rin ng titrate mo to. Okay? However, actually itong redox, start na ito ng parang, papunta na sa instrumental kasi hindi na P-function ang nandito, eh. Usually, electrode potential na siya or E. So, E-cell nga 'to usually, eh, or yung E-mixture mo, yan. So, yung E-cell mo na ngayon yung kina-calculate natin. Please take note Josh, ang E-cell natin ay E-cat minus E-anode, 'di ba? E-red minus E-ox. Naalala mo pa yun? Anong ano yun, anong topic 'to? Para makuha yung E-cell?
Yung sa, ano, parang ko yung isel.
Oo, electrochem. Electrochem yan, nag-calculate na tayo dati.
Opo.
'Di ba sa electrochem, anong formula ulit ng E-cell? Eh, ang cell mo dalawa, eh, cathode and anode.
Pagmana sa ion anode.
Okay, good. Cathode, E-cathode minus E-anode. Sa equivalence point dapat, Josh, ang E-cathode mo equals yan sa E-anode mo kaagad. Okay? That will be, E-cathode and E-anode will be equivalent. Don't worry, Josh. We will still, depende yung ano nito, no? Yung ano ang tawag dito. Um, hindi sigmoidal usually ang nabubuo dito, eh. Line segment na ang nabubuo dito, eh. Parang pa ganun yan usually, eh. Tapos may equivalence point tapos gaganyan na siya. Kasi nga ito ay ano 'to, eh, ano ngang tawag dito? Reading siya, 'no, instrument reading. So this is an instrument response or IR. IR na iba pa yan sa infrared, ha. So, ang meaning ng IR diyan ay instrument response or instrument reading. So, technically yung redox mo, well, once you have the E cell as your y-axis, hindi sigmoidal ang nakukuha mo diyan usually. Usually yung line segment curve, yung pa gano'n. Mali nga yung pagkakakuha ko, wait lang. Pero parang tama yun, kasi alam ko nagmi-mirror yan, eh, yung kasi parang mirror nga din yung ano mo, eh, sigmoidal curve mo, okey? So, nagmi-mirror siya dun sa mismong ano natin, um, sa cathode and anode, lines mo, okey? So, next. So, we'll now proceed with the different stages for your titration curve. So focus ulit tayo diyan siya, focus ulit ako sa acid-base titration. Okay, acid-base titration. So far, ang gagawin ko muna Josh, yung una nating example, strong acid versus strong base. So when you say strong acid versus strong base, ang nauuna ay yung analyte mo. So this will be your analyte. Yung sumusunod will be your titrant. So sinong analyte mo Josh for this strong acid and strong base? That will be your acid. Tapos yung titrant mo si strong base naman. Uy, wag mong ano yan ha. Paano pag sinabi ko Josh, strong base versus strong acid titration?
Opo,
Naku, wag kang malilito diyan. Sige. Paano pag strong base versus strong acid?
siya yung
Sinong
ano,
titrant?
titrant is the acid.
Very good. Tapos si strong base yung magiging analyte. Ganito yung para 'pag tinuturo ko sa class ko, lagi mong tatandaan, analyte is letter A. So siya ang mauuna. Ayan 'no, letter A. Tapos titrant ay letter T. So siyempre mas mahuli siya sa alphabet. So siya yung mahuhuli ngayon. So again strong acid is your analyte and strong base is your titrant for this one. So if you will notice Josh, ilang stages ang makikita natin sa sigmoidal curve? Ilang stages kaya, Josh? Sige nga, how many stages do we see for the sigmoidal curve?
1,
Sige, bilangin mo, ilang stages yan?
1.
One lang?
1 lang po yung nakita ko. Yung basta
Uy,
naka-share.
hindi. Oo, syempre, ang one kasi ay initial.
Opo,
So, ibig sabihin ng initial stage? Wala pang titrant na dinadagdag. So,
opo,
as is yung analyte mo, as is yung sample mo, as is siya. Tapos ang susunod na stage ay ito, the pre-equivalence stage or before equivalence point stage. Okay? So again the second stage is the pre-equivalence point stage or the before equivalence point stage. Ano yung third stage natin? Ang third stage mo talaga na yun, ngayon Josh, ay very important din to, the equivalence point stage. So kung saan nag-equal na yung acid and base mo, no? And then finally, your fourth stage will be the after equivalence point stage or post equivalence point stage. Okay? So, isa-isahin natin siya, no? So, baka bukas, by the way, Josh, either tomorrow tayo magkikita or sa Thursday, ha? I'll update you. Kapag maaga ako nakauwi bukas kasi nasa office ako tomorrow, no? Maaga naman akong uuwi, try ko siya. We can meet, no? Around, let's say, 3 to 5 ulit or 4 to 6, no? Tomorrow. I'll update you.
opo,
So, yan yung i-discuss natin tomorrow. Pero syempre, simulan ko na no, yung parang basic discussion. Para tomorrow, calculate kagad tayo. Magka-calculate kagad. Okay? So, this is the general shape of your titration curve. Same pa rin naman, no? Strong acid versus strong base. Okay? So, actually mali ito kasi acetic acid dito. Ano ang acetic acid mo dito? Weak acid yan. Iba ang itsura niya pa. Later may kita mo or i-discuss natin kung ano yung mga differences, no? For a strong species versus strong species, then weak species versus a strong species. So, depende kung ah, strong acid versus weak base or strong base versus weak acid, etc. Okay? So, yan, like what I mentioned, may apat tayong stages. The first one is the initial stage. So, anong volume ng titrant mo sa initial stage, Josh? May dinagdag ka na bang titrant sa initial stage? This is very important. Oh, you listen now. Ito na yung last slide natin for today.
Ano?
Sa initial stage, anong masasabi mo sa volume ng titrant?
Wala, hindi pa po nilalagyan.
Very good. Kapag pre-equivalence point stage, anong masasabi mo sa volume ni titrant?
Volume na titrant, meron na siya,
Mm.
pero not yet equivalence point.
Very good. It's greater than 0. However, it must be less than the volume at equivalence point. Okay? So, during the stage 3 naman, during the equivalence point stage, this time, the volume of your titrant becomes equal to the volume of your equivalence point. Okay? And then, of course, the stage 4 will be the post-equivalence point stage. The volume of your titrant is greater than the volume of your equivalence point stage. No? So, or volume at equivalence point. Okay? So, ibig sabihin, sa number 4, Josh, madali itong i-explain eh. Yung 4, sobra na yung titrant mo. Yun lang yan. In excess. So, in excess ito. This is another, another point of view. Pag post-equivalence stage or post-equivalence point stage, in excess ngayon ang titrant. Josh, sino yung in excess kapag pre-equivalence point stage?
Nandun na may
Pag pre-equivalence point stage, sino ang in excess?
yung yung, analyte mo.
Very good. Yung marami pang analyte. Hindi pa kasi nga nagkakaroon ng equivalence point eh, no? So si analyte ngayon yung marami. Siya yung naiiwan. Ngayon, ito yung technique diyan, Josh. I-a-analyze mo kung sino yung naiiwan kapag regardless kung anong type to ng titration na strong acid, strong base, strong base, strong acid, weak base, strong base versus weak acid. So i-analyze mo ngayon yan, Josh. So that you can determine anong type ng calculation yung need mong gawin. Okay? So what type of calculation you need to do? Okay? So tignan mo dito ito yung sisimulan lang natin umpisa lang sa stage 1. So, ito yung example natin magta-titrate daw tayo ng 50 ml, 0.1 molar nitric acid and 0.1 molar NaOH. So, wala pang volume si NaOH sa stage 1. Yun lang muna. So, meron kang 50 ml na 0.1 molar HNO3. Let's start with the initial stage. So, dito tayo matatapos. Sa initial stage, madali kasi yung calculation natin eh. Your volume of titrant is 0. So, only the analyte is present. Sa binigay kong example, Josh, sino yung analyte mo? Yes, Josh? Sino yung analyte mo, Josh?
Yung mo, tawag doon? Dito, it's, titration and nitric acid.
Very good, nitric acid. So, siya lang yung nandoon. Kasi wala ka pa, initial stage pa lang tayo, stage 1, no? So, please take note, at initial stage, the pH of the solution depends on the nature of your analyte. So, if the analyte is acidic, so of course, the pH solution should be less than 7. If the analyte is basic, the pH solution is greater than 7. So, parang ang tanong mo dito, ito yung guide question mo dyan. Pag initial stage, Josh, is your analyte acidic or basic? Is your analyte weak or strong? Balik tayo dun sa example ko. Sino ulit ang analyte, Josh?
Analyte si nitric acid.
Okay, so it's an acid. Is it a weak or a strong acid?
It's a strong acid.
So what is the pH? So kasi yun ang initial pH mo ngayon. So what is your initial pH?
I don't know. Basta 0 mo, I think.
Hindi paano mo i-calculate mo ang 0.1 molar pH of a 0.1 molar HNO3?
Negative log.
Oh, grabe, kinalcule niya pa.
1. Okay.
Bakit mo kinalcule pa yan? Negative log of 0.1. Good.
I
1
forgot.
yan.
Yung tawag na I forgot.
So, kasi you're given with 0.1 molar nitric acid. So, i-negative log mo lang yan, yung concentration, pH is equal to 1. That's the initial pH. Ngayon, makikita mo ha later, tomorrow 'no, most probably tomorrow mamimit kita. Aangat ng aangat 'yan. Pero hindi 'yan ano, biglang angat, oo, makikita natin, gradual muna yung increase until we're quite close with the, equivalence point. Dun medyo tumataas ng malaki yung change 'no, delta PH, per point 'no. So, tomorrow we'll move on with the next stages, stages 2, 3, and 4 'no, and then we'll try to generate a titration curve for this problem, 'no? Tomorrow din bibigyan naman kita ng problem, ikaw ngayon ang mag-generate ng titration curve and then let's check 'no, kung anong mga properties ng titration curve and we'll try to, hindi pala will try, we will, create or generate your titration curve using your, Excel. So ikaw magse-share ng screen 'no, so gusto ko maano mo 'yan, magawa mo 'yan um sa Excel. Okay? So, yeah, I think that's it for today. So, tomorrow we'll just continue this one, Joshua, and I'll see you tomorrow. Okay?
Okey
Uy,
po.
na-check mo pala yung ano, yung recording?
Opo,
Complete naman siya?
complete naman po siya.
Okay, sige. So, hopefully this recording is also complete. Okay?
Okey
I'll see you tomorrow, Josh.
sige
Thank
na po.
you.
Ba-bye po.
Mhm.